I'll be discussing about distributed system, its examples and some characteristics. Well, the outline that I am going to cover in the presentation today is what is a distributed system, what actually do we mean by distributed system, some examples of distributed system, some common characteristics of distributed system, and lastly the summary. So, here comes the definition of distributed system. What is distributed system actually? A distributed system is one in which components are located at network and computers communicate and coordinate their actions only by the passing of messages. See, this is a very, just take care of this particular terms, components, the coordinates, the passing of messages. If we talk about components, what are actually components in distributed system? See, it can be a type of a node that is actually connected with a computer, that is actually connected with a particular network, we can say. So, it is one in which we are having different components and they are basically located at networks. Okay, that means the node that are actually located at the network system, and they or these nodes or these computers, they basically communicate and they coordinate their actions simply by the passing of the messages. So, if we talk about this particular definition, it actually leads to some important characteristics of distributed system. Now, what are those very characteristics of distributed system? Initially is the concurrency of components, that means the components need to be concurrent. Second is the lack of a global clock, there is no global clock in distributed system. Third is the independent failure of components. See, the components are located at the network location, so they can be independent failure of a particular component. So, they are basically three characteristics as per the definition of distributed system, that is concurrency of components, the lack of global clock, and lastly the independent failure of components. Now, if we talk about centralized system characteristics, what is actually centralized system? In which we are having a particular central system. Fine, there is a single point of control in centralized system. One component with autonomous paths we are having, then components shared by all the users all the time. Fine, then there are resources that can be accessible. Software runs in a single process. Fine, that is why the name, the centralized name, that means there is a centralized control. Software basically runs in a single process. Okay, so there is a single point of control, there is a single point of failure. This we are actually talking in terms of centralized system. This is not a distributed system, this is a centralized system. So, these are the different characteristics of the centralized system. They can be single point of failure, similarly a single point of control. That means there is one point which is actually controlling the complete system. Okay, and if that particular system fails, the whole system is going to fail. So, there is a single point of failure too. Now, let us discuss about the characteristics of the distributed system. In distributed system, as I told you that there are different components and they basically communicate and coordinate by the passing of messages. Fine. So, in this we are having the multiple autonomous components. The components are not shared by all the users. Fine. Then resources may not be accessible. See, all say for example, we are having different components and different components actually are interested in accessing a particular resource. So, they may not be accessible. Fine. Then software runs in concurrent process on different processors. So, there may be number of different processors and the software runs on concurrent processes. There is multiple point of control. Fine. In centralized system, we are having a single point of control, whereas in the case of distributed system, we have multiple point of control, because we are having number of nodes and those nodes, they basically communicate and they coordinate their actions simply by the passing of messages. That means we are having multiple point of control. Lastly, the multiple point of failures. Okay, in distributed system we can have multiple point of failures. It is not like that as we have studied in the case of centralized, there is a single point of failure. In the case of distributed, there can be multiple point of failures. Now, let us come to the benefits of distributed system. Why we are using this benefit? Why we are using this distributed system? The first is the horizontal scalability. What do we mean by scalability? See, Since computing happens independently on each node, it is very easy and generally inexpensive to add additional nodes and functionality as necessary. That means if you are quite interested in adding an additional node, if you are quite interested in adding an additional functionality, that is actually possible in the case of distributed system. Okay, and it is inexpensive also. As we are talking about computing and it is happening independently, at EC we are having number of different nodes, and each particular node the computing is actually taking place. So it is quite easy, as well as in terms of money it is quite inexpensive if we are quite interested in adding any additional nodes as well as the functionality as far as our requirements are concerned. Then comes the reliability, which is the most important feature. What is actually reliability? Why do we want a system to be reliable? Why do we want a particular network to be reliable? Right? Most distributed systems are fault tolerant, as they can be made up of hundreds of nodes that work together. The system generally doesn't experience any disruptions if a single machine fails. That means it is not like that, like if you are having different nodes and there is a single machine failure, the system is going to crash. No, it's not like that. So that means it is something which is very, very important, and this is definitely going to provide you with the reliability. Okay, the probability of failure-free operations, how good the system is, how good the network is. So based on that we can say that it is one of the most important benefit or the advantages of using any distributed system. Then comes the performance. What is performance? Why do we want a system to be a better system in terms of the load that it is having and all? So distributed systems are extremely efficient because workloads can be broken up and sent to multiple machines. See, whatever is the load that is actually there in the complete system, and we are having number of different nodes and the number of different systems. Nodes, system are basically, I mean, the same thing. Okay, so that particular node can be broken up and then can be sent to different multiple machines. So in terms of performance, it is extremely efficient, which is again one of the most important advantage of this distributed system. Okay, there is scalability, there is reliability, there is performance. We always want the system to be a performative system. We always want the system to be a reliable system. We always want a system or a network to be a scalable system or a scalable network. So these are different benefits or the advantages of the distributed system. Now, as far as we have studied, there are different benefits or the advantages of distributed system. It also comes with number of different challenges too. So that means there are some challenges also in distributed system, though it is having number of advantages also. What is the first challenge? The first challenge is the scheduling. What is actually scheduling? See, a distributed system has to decide that which jobs need to run, when they should run, and where they should run. This is very, very important thing, that it is a system, this particular system has to decide that out of number of jobs, out of number of nodes that we are having in a particular system, okay, which job is going to run, the timing, what is the exact timing when that particular job will run, at what particular machine they will run, where they should run. So schedulers ultimately have the limitations. Definitely we are using the scheduling, definitely we need to we are having different scheduling algorithms also, but these schedulers, they definitely have some limitations, okay, which leads to underutilized hardware and unpredictable run times. So if you are going to schedule, scheduling is, of course, we are going to schedule it. There are different algorithms. We'll be using one or the other algorithms with the help of which scheduling need to be done. Which job is going to run, when they are going to run, where they should run. But when we are going to use it, it is definitely having some limitation, due to which we are not able to utilize this hardware and all properly. Okay, so this is the most, the biggest challenge of this distributed system. Then comes the latency. What is latency? The more widely your system is distributed, the more latency you can experience with the communication. It is not a standalone system. It is not a type of system that we are doing as a type of isolated system. It is a distributed system. Okay, and we are having number of nodes which basically communicate each other by simply the passing of messages. So we are having a very, very wide system. That is why we are calling it as a distributed system. So the more wide the particular system is, okay, the more widely your system is distributed, the more latency we are going to experience with the communication. This often leads to teams making trade-offs between the availability, the consistency and the latency. Okay, availability also is one of the most important feature. Consistent, we always want the system should be available. Say I want to access the system at any particular instance of time and the system is not available. Do we think it is a good, it is a good scenario? No. So we always want the system to be available. We always want the system to be consistent depending on the type of requirements that we are having. So latency again is one of the biggest challenge of distributed system. Now there comes the observability. What is observability? Gathering, processing, presenting and monitoring the hardware usage matrices for large clusters is a significant challenge. See, we have to gather the processing. That means processing that is done at particular node and then the processing done at another. We are having as different nodes. Fine, and different processing are actually taking place at different nodes. So we have to gather those processing. We have to present it. Then monitoring the hardware usage, how actually the hardware is used. We have to monitor it. Okay, and for large cluster, we are having a large cluster in which we are having the multiple nodes and all. This is again a big challenge. So though it is having a number of advantages and benefits, similar to that we can say like whatever things we are having, similarly we can say that as we cannot actually ignore the challenges of distributed system. Right? So scheduling, the latency, the observability, okay, the how the scheduler is going to work, what are the limitations if we are going to use that type of schedulers, okay, what is the type of how actually the hardware is going to underutilize. So these are different type of challenges. Now next comes the examples of distributed system. Local area network, fine, LAN is the example of distributed system. Intranet, we are having intranet, that is again the example of distributed system. Database management system, which is actually used for managing the data, that is again the example of distributed system. ATM machines, automatic teller machines network, that is again the example of distributed system. See, you can see that in all these examples that are actually mentioned here, we are having different nodes, okay, and they basically exchange the information, the data only by the passing of the messages. Internet again is the example of distributed system. www, the World Wide Web, is again the example of distributed system. Mobile and ubiquitous computing. So these are different examples of distributed system. Now this is basically a local area network. As you can see, there is a local area network in which the web server, the email server, the file server, that is basically connected with a particular LAN. Fine, there is email server, we are having like the desktop computers, the other servers, the rest of the internet, they are basically connected with a particular LAN. We are having different routers, the firewalls, that means only authentic message. We are having some checks or the mechanism that that only authentic message will be able to access and all. Fine. So this is basically the example of the local area network, in which we are having the different number of servers, the web servers, the email server, the file servers, the routers we are using, the firewalls, the different desktop computers. So this is the example of your distributed system, because this is not a type of standalone system. Okay, this is not a standalone system, we are having different machines. So that is an example of distributed system. Now next comes the database management system. We are having different machines in which you are having different processes. Say for example, we are having different processes like application 1, application 2 up to so on application 3. Then the database engine, and that particular database engine is connected with the database monitor. Okay, and we are having different database 1, database 2, database 3, and we are going to display it. So this database system, what actually this database system is doing, this database system is going to manage the complete data. We are having a huge amount of data, we are having a bulk of data. Okay, why we are using this DBMS, database management system, okay, a method or a way or a system with the help of which we will be able to manage a huge amount of data. There's a network inter-process communication. There is OS communication to some external device. So this is again an example of your distributed system. Now next is the automatic teller machine network. there is basically a teller machine, and that teller machine is basically connected with your computers that are controlling these teller machines. Okay, and then these computers which are controlling these teller machines, they are basically connected with your computer that is holding the bank account data, okay, or any other controller. I mean the controller which is actually holding the account, the complete information of the bank, the complete information of the bank account data. That is again hot standby, that is holding the secondary copy of the bank account data. Fine. So, this is actually the working of this ATM network or the ATM machines that we generally use in our day to day life. This is again the example of the distributed system. Okay. So, these teller machines, they are basically connected with the computer which controls these teller machines. Further, this controlling of this teller machines, it is connected with your computer which is holding the information of the bank account data, and then the standby holding, that is holding the secondary copy of the bank account data. So, this is again the example of the distributed system. Now, internet, as we all know what is actually internet, it is the global connection of computers. Okay, internet is the global connection of computers. We are having different desktop computers, servers, different network lines. Okay, and then we are having the satellite link which is actually the backbone of the whole system. This is also the example of your distributed system. It is basically the global connection of computers. Okay, network of networks, internet. Now, next comes the World Wide Web, WWW. Now, what is actually WWW? It is commonly generally referred to as web also. We sometimes call it as WWW, sometimes we refer to it as web also. It is basically the information system that is having or combining all the details or all the information where documents and other web resources are identified by the URL. That is important thing. Okay, it is basically the information system, okay, the system which is going to maintain the information, which is having all the information, whatever the documents in this will be having different documents. So, all these different documents and the other web resources, they are basically identified by the URL, that is the uniform resource locator. Okay, so as you can see here, such as HTTPS hypertext transfer protocol, this example.com, which may be interlinked by this hypertext, and they are accessible over the particular network. Now, next comes is the mobile and ubiquitous computing. What is mobile and ubiquitous computing? Yes, this is also the example of your distributed system. The portability of the device such as the laptop computers that we are using in our day to day life, the PDAs, the mobile phones, the refrigerators, together with the ability to connect conveniently to the networks in different places, make mobile computing possible. That means we can access or we can actually connect with the person sitting so far from us. These all are the type of devices that actually makes this computing possible. Ubiquitous computing is the harnessing of many small cheap computational devices that are present in users' physical environment, including the home, the office, or anywhere. They can access it from anywhere. So, mobile and ubiquitous computing raises significant system issues which are present in architecture for mobile and outlines the issues which basically arises from it. Now, what are those very issues which arises from it? How to support the discovery of the resources. Okay, if you are having the resources, we definitely will be using these very type of resources. So, how to support this discovery of resources in the host environment? Eliminating the need for the users to reconfigure their mobile devices as they move around. Then again, it is helping users to cope with limited connectivity as they are going to travel. And also it provides the privacy and other security that is guaranteed to the users and the environment that we are going to visit. See, security again is one of the most important feature. So, that means it is simply going to provide the privacy as well as the security, and it is definitely going to guarantee the users and the environment that they are going to visit. So, this is again an example of the distributed system. Now, let us discuss about the common characteristics of distributed system. What are the different characteristics of distributed system? What we are trying to achieve when we are constructing a distributed system? What is actually the aim behind constructing the distributed system? That is the important question. There are certain common characteristics that can be used to access the distributed system. These are the important characteristics that we will be going to discuss one by one. Initially is the heterogeneity, then comes the openness, the security, the scalability, the failure handling, concurrency and transparency. When we are constructing a distributed system, or when we are constructing say for example a centralized, whatever system we are going to construct, what is actually the aim, why we are trying to achieve, what is the aim at the end. So when we are trying to achieve, what is the aim, what is the basic characteristics that we are actually expecting from the system. Now what is heterogeneity? What do we understand by this term heterogeneity? Homogeneous, as you all know, means the same type. Heterogeneity means variety, different forms. So variety and difference in networks, different type of networks. Okay. Then comes the computer hardware, different type of hardwares, different hardwares will be using it. Operating system, different operating system, different programming languages. Okay, we are having multiple or number of different languages which are present today. So we are having different programming languages, the implementation by different developer. So it is not a straightforward rule that there is one developer and he or she is going to use a particular language. You are going to implement it by different developer. That means there is a heterogeneity. Okay, we are having different layers in the as we are going to talk about the structure of this particular DS. We are having the middleware. So what is the working of this middleware? Middleware as a software layer to provide the programming abstraction as well as masking the heterogeneity of the underlying networks, the hardware, the OS and the programming language. Then comes the mobile code. What is mobile code? It simply refers to the code that can be sent from a particular computer to another and that runs at that destination, like the Java applets and the Java virtual machine. So it basically comes in the variety and differences in the networks that we are using, the computer hardware that we are using, the operating system we are using, the programming languages we are using, and the way with the help of which the developer is actually going to implement it. Fine. So this is the important characteristics of distributed system. It is heterogeneous. It is heterogeneous in nature. Heterogeneous means of the different type. Varieties in the form of difference, difference in the form of networks, in the form of hardwares, in the form of OS, in the form of programming language, in the form of implementation type by any of the developer. Now next comes is the openness. What do we understand by this term openness? This is the second characteristics of the distributed system. It is basically concerned with the extension and the improvement of distributed system. We always want that the system should be open system. If we want to extend the system, it should be possible that if we want to extend it, it is possible. So it is basically concerned with the extension. If you want to improve the system, that should be improvable. Until and unless the system is not improvable, the system is not extendable, the system is of no use. So it is basically concerned that if you want to extend the system, that should be possible. If you want to improve the system, if you want to add a system, if you want to enhance the system, that is actually possible. See, right now we are having 10 nodes, okay, and if you want to incorporate some more nodes, that should also be possible. So that is what is actually the meaning of this term openness. Next comes is the detailed interface of components need to be published. As I told you, we are having different nodes, we are having different components, okay, which are completely which are there at your the complete network, and they basically communicate and coordinate simply by the passing of messages. So the detailed information of these components, that again need to be published. That is what the openness is. New components have to integrate it with the existing components. Presently, say for example, we are having 10 components and we are adding some more components, 2 or 5 or 10 components we are adding more. So those new components, they need to be properly integrated with the present system that we are having right now. So they have been properly integrated with the existing system or the existing node which are present in the particular distributed system. Now differences in data representation of interface types on different processors or different vendors have to be resolved. Fine. That means if there is any difference in the representation of the data, we are going to represent this particular data, and if there is any difference in the representation of the data of the interface time or any different processors, that need to be properly resolved. So this is again an important characteristics of distributed system. Next comes the security, which is the most important characteristics of DS. What do we mean by security? See, we always want the systems should be secure. No one wants that the system should be unsecure. So, in a distributed system, the client sends the request to access the data that is managed by the server, the resources in the network. Security is required for concealing the contents of the messages. We always want the data should be secure. We always want the data, if we need to maintain the privacy of the data. We need to identify the remote user or other agents correctly. Authentication is required. Confidentiality of the data is required. Integrity of the data is required. We always want that the data should be confidential. What does it mean? What do we mean by this? That the data should not be accessed by the person who is not actually like authentic to use or to access that data. The data should be confidential. It should not be leaked. The data should be in the integrated form. The data should be available when we want to access the data. See, we have the data and the data is available, but we are not able to access the data. The data is not available when we want that data. Will the data be of any use? No. We want the data to be confidential. We want the data to be available. We want the data to be in the integrated form, in the complete form. So, security is quite important. Okay, the confidentiality and the authenticity of the data need to be properly managed. Then comes the new challenges. Again, the denial of service attack. Whatever a particular node has sent, whatever the data the particular node has sent, after sending that particular data, that particular node should not deny from this fact that I am the one who has sent this particular data. Then security of mobile code is again the new challenge. So, we always want that the system should be secure enough, the system should be reliable enough, the system should be confidential, the system should be authentic. Only the authentic user should be able to access the data. The one who is not authentic, is not having the access to fetch that particular data, should not be able to fetch that data. So, we always want the data to be secure. This is again the important characteristics of DS. Now, next comes is the scalability. What is scalability? Adaptation of distributed system to accommodate more users. That means the system should be scalable. How we can accommodate more user? It is only possible it is only possible if and only if the system is scalable. If the system is not scalable, we cannot accommodate the more users if we want. Then again, respond faster. This is again hard one. How the system is responding, how much time that particular system actually needs to respond to a particular query, that is important thing. We always want, each of us wants the quick response from the system. We want a system like you have sent a particular query and that particular query is taking quite an hours. So, how fast the system is responding, that is again important. So, it is basically the adaptation of the distributed system to accommodate more users, whatever the number of users, how the system is responding fast. Now, it is usually done by adding one and faster process. Okay, by using any, it is basically done by adding more faster processors. That means we are supposed to add more processors, good fast processors. If you are having fast processors, definitely it is going to run fast, it is going to respond fast. Then components should not need to be changed when scale of system increases. See, when we are having a big system, okay, then components should not be need to change when we are talking in terms of the scalability. Then design components to be scalable. Okay, scalable simply means the adaptation of the DS according to the type of users, what the number of users we are having. So, the system, we always want that the system should be a scalable system. That this is again the important characteristics of the distributed system. Now, next comes the failure handling. Fault tolerance. What is failure handling? See, if a type of failure is occurring in a particular node, we cannot say that the system, that the whole system or the whole distributed system is going to crash. What is actually the ability, how nicely you will be able to handle that particular fault if it is occurring. So, this hardware, the software and the network fail. See, if you are dealing in terms of the hardware, if you are dealing in terms of the software, if you are dealing in terms of the networks also, they definitely may fail. So what is actually the probability, and what can actually we do? How we are going to handle if any type of failure is occurring? If there is any type of failure in the hardware, how we are going to handle it? If there is any type of failure in the software, how we are going to handle it? If a particular network fail, how we are going to handle it? What is the fault tolerance capability of the system? Distributed system must maintain the availability even at low levels of hardware, software, network reliability. As I told you, availability is one of the most important feature. So it should maintain the availability even at the low levels. We have the data and the data is not available to us. So that data is of no use to us. So it should maintain the availability at all the levels of hardware, the software and the network. Reliability. We always want that the system should be reliable. The system should be trustworthy. It should be able to produce some good results. What is actually the probability of failure-free operations? That the system is not going to fail. Now, fault tolerance is achieved by this recovery and redundancy. Now, what is recovery? How we are going to recover if a particular data is lost due to any or the other reason. We have the data, we have a huge amount of data, we are having different nodes and all, and the data is stored at those nodes and all. So, if due to any or the other reason that data is lost, what are the mechanism we are having based on which we will be able to recover this particular data? We are having different algorithms also, with the help of which we are going to which we are going to actually apply, based on which we simply try to recover the data. We should try to take the backups of the data. How frequently we are going to take the backup of the data? See, whenever we are going to make any type of updation in the data that we are having, we are going to take the backup of the data. A secondary copy of the data need to be properly maintained. And when we definitely, if due to any or the other reason the system there is any problem in any particular node and the data got lost, no issue as such, because we have already maintained the data at some other point, at some other location. So we definitely will be going to, we'll be easily able to fetch that particular data. So this failure handling, this is very, very important, and we need to properly handle the data, or we'll need to properly recover if there is any type of failure in the data. Now next comes is the concurrency. What is concurrency? Components and distributed system, they are executed in concurrent process. Okay, we are having different components, and in DS they are executed in the concurrent process. Components access and update the shared resources, example the variables, the database, the device drivers, so they need to be updated. Integrity of the system may be violated if concurrent updates are not coordinated. Integrity of the data need to be maintained. The data should be available in the complete form, and again this is an important feature, and this again can be violated if concurrent updates are not coordinated. That means you are not actually taking the update of the data. When you are going to take the update of the data, that is not properly maintained. So that is so definitely we are going to violate with the terms of this integrity. Lost updates, we have updated the data but we have not maintained it. So definitely the update is going to lost. Inconsistent analysis. So the data need to be properly need to be concurrent in nature. Then comes as the transparency. What is transparency? The distributed system should be perceived by users and application programmers as a whole, rather than as a collection of cooperating components. See, if you are talking about distributed system, they should be perceived by different users and the different application programmers as a whole, rather than we are simply collecting a particular cooperating component which is having a type of communication, or a particular node is having a communication with some another node. Transparency, of course, definitely it has different aspects. These basically represents the various properties that distributed system should have. Okay. So when we are designing, or when we are actually interested in making a particular distributed system, these are the features, or these are the different properties that every person whosoever is designing or making or building the particular distributed system should definitely going to include these very type of property, that the system should be transparent, the system should be open, the system should be scalable. The system should be heterogeneous in nature. The system should be secure enough. The system should be available. The system should be confidential. So, these are basically different properties which the distributed system that we are going to have, that we are going to design, should be there. Now, next comes the summary. Sorry, the definition of distributed system and the comparisons to the centralized system, the characterization of the distributed system, the different forms of transparency. Fine. Transparency, as I told you, is one of the most important feature, and we are having different type of transparency also, based on which we can actually, based on which we can actually say is what the main how the system actually can be transparent. So, what we have studied is basically the distributed system. Fine. Some examples of distributed system we have studied. Then comes the different characteristics. So, while we are going to make a particular system, the main thing is that like how we are going to incorporate those particular type of characteristics in the system. That actually is the aim. Thank you so much.